Thanks for watching. We're talking about PIM modes. It's going to get better. There's a lot of concepts to introduce. IPv4 subject matter expert for a number of years for big companies. I'm doing this based on my experience. Okay, the PIM, protocol independent multicast, is how we're routing between layer 3 interfaces. You need to turn on. Needs to be enabled on all the interfaces. That's not just where my I expect the traffic to go, but I need to make sure that if it needs to leave this device that I'm on, that all the uplinks going to wherever else the traffic may need to go are PIM enabled on both sides of the link. If you don't have a neighbor, it's not going to work, or it's not going to get there. There are variants. One of the first dense mode. This is sort of a broadcast. I just start telling people I want this traffic. I tell people that their traffic is there. And there's a mechanism with timeouts where essentially we're going to I get it from one PIM neighbor. I'm going to tell all my other neighbors about this, and it's going to go to the edge of the network. And until everybody's got a chance to basically know that I've told everybody about it to all my neighbors, and then they all get to stop, figure out that no one wanted this traffic in case it's a sender, and then turn back. And this will repeat itself periodically. Not supported on the newest platforms. It doesn't require a rendezvous point. It doesn't do shortest path trees. That the more common at this point is you're going to run into often referred to as any source multicast, ASM, sparse mode. It needs a rendezvous point. It needs a place that we commonly know where a device that we're telling it learns about all the sources, and everyone who is asking for traffic knows to go to find out if there are sources. It uses both shortest path trees and shared trees. Sparse dense is a cheat. Name kind of implies that. The idea is, and why so many vendors did this for so long, doing rendezvous points right has some challenges to it. So if I do it, if I advise you, your Vocera install manual, I have you do this as sparse dense. If they mess up sparse mode, it falls back to dense. Problem is that it's just going to not support it anymore. So no more sparse dense. Your source specific, that's more interesting. It doesn't use a rendezvous point. How the last hop router knows where the sources are. There's a number of ways, including some that require out of band. So the application itself has to have some method of knowing where the sources are. There's no shared trees because there's no rendezvous point. And one of the things you're supposed to do is define all your devices where, if you see this range, it is source specific. Okay, and then bidirectional, there's some big applications for it. According to my instructor, it was always like, oh, you don't want to do this, you don't have to. I have never turned on a biter. Biter forces everything through. The rendezvous point is it has a particular exception. Normally, I do not send multicast traffic out the interface that received it. Really, the idea is that if there are other PIM neighbors, the one who first gets the source should be sharing it with the other PIM enabled interfaces on this say it's like a Metro Ethernet, right? That I should be dealing directly with my neighbors. If I'm received it from someone else in this MO, I shouldn't be sending that out. But biter is an exception, and it's very specifically. It's not PIM mode in the same way, but you need to enable bidirectional and global on this one. So a lot here. Most common you're going to run into is going to be sparse mode and source specific, or at least going forward. Okay, thanks for watching. You can subscribe to my channel, suggest additional topics. There's a lot to talk about. We're going to do a lot of these. So don't worry if this makes no sense yet. We're getting there. So thanks for watching, and subscribe, like, all that good stuff. Thanks.